In the first video for Experiment 1, I introduced you to the basic principles of measurement. In this video, we'll be looking at the data and report pages, the actual meat of the experiment, and those pages where you might lose some points, and so we want to give you as much help as we can. So let's jump into the data and report. Every experiment begins with a calculations and report page. It's located right before the data and report pages themselves. And if you have a question about something that you're filling in, chances are that calculations and report page would help you. So it would be your first line of help. Let's look at the first data page. It's called the PreLab review. It's a page before we actually get to the actual data page. And the PreLab review asks a series of questions. The very first question is always, are there any safety alerts? Well, most of the experiments will have those, but this one doesn't. The second question, too, is the same from one experiment to the next. It asks if there are any disposal directions, and there are none for this experiment. Question 3 says that a quantity has a measured value of 8.4126, and which of the 5 numbers has an uncertainty? Well, this gets us to the definition of significant figures. There are always numbers that we're sure of, plus one more that's an estimate. So we're sure of the 8, we're sure of the 4, the 1, we're sure of the 2, but the 6 is an estimate. So that's where the uncertainty lies. Question 4, how many significant figures are contained in each of the following measurements? Well, this is sort of an exercise on using rules for significant figures. We know all the digits are significant. The only question comes in which zeros are significant. And we've told you in the text that trailing zeros, as we treat them anyhow, are always significant, and leading zeros are not. So these 2 zeros are not significant. The 0 in the middle is. And so knowing the rules for zeros will allow you to specify how many significant figures are there. Question 5 asks, what is the uncertainty, a plus or minus a certain amount? That may be an expression that you're a little bit unfamiliar with. Let's look at this middle one and work it out and leave the other 2 for you. 7.56 milliliters. Well, I know the 7, we're sure of it. We're sure of the 5. The 6 is an estimate. It could be a 5 or it could be a 7. Or in other words, this value is plus or minus 0.01. That's what we mean by the uncertainty. Question 6 deals with a measuring device that has divisions to the 1/10. It's a little bit like the rulers that we'll use in this experiment. Ruler A has markings to the 1s, ruler B has markings to the 10th. And the general rule for using a measuring device is that we estimate one more place than the number of markings. And so for ruler A, with markings to the 1s, we'll estimate to the 10th. Ruler B, with 10th markings, we'll estimate to the 100th. So this is like ruler B. We'll estimate to the 100th. Question 7 gives us a little more practice with significant figures. Here we'll have to do some rounding. And the number in parentheses says that we would like to round this number to 2 significant figures. Well, I know the 0 is not significant. The next 0 is not. The 1 and the 5 are significant. That's 2 significant figures. But I have to look to the next digit to see if we round up or round down. And if it's 5 or greater, we round up. So correctly rounded to 2 significant figures, it would be 0.016. Number 8 Again, gives us a little more experience with significant figures. This time we're adding and subtracting, multiplying and dividing. Two different operations, and we have two different rules. If we're adding and subtracting, we count decimal places, and it's the least number of decimal places that wins. For multiplying and dividing, we count significant figures. And there too, it's the least number of significant figures that wins. Here's the first data and report page now. This is part A, measurement with ruler A. And ruler A, I mentioned, has markings to the ones. The grader, when they look at your data for this part of the experiment, will make sure that every measurement is recorded to the 10th. So I've recorded just two hypothetical values for rectangle W to the 10th. Table 1.2, I've repeated those values here for the length and the width. And the second column asks how many significant figures are there. Well, of course, there are 3. All the digits are significant. And that comes into play in the next table, where we're going to be multiplying. We'd like to calculate the area of rectangle W, and you know that the area is the length times the width. We had 3 significant figures in the length, 3 in the width. 3 is the smallest number, so the correct number of significant figures in the calculated area is going to be 3. The calculated area, this is what my calculator tells me. And over here now, I'm going to round the answer to 3 significant figures. Table 1.4, we're doing a little different operation with ruler A here. We're calculating the perimeter. And to calculate a perimeter, you add the length plus the length plus the width plus the width. And when we add, we count decimal places rather than counting significant figures. And ruler A was expressed to the 10th, so we're going to have 1 decimal place. Over here's what my calculator tells me as I added up those numbers. And well, it is expressed already to the 10th, so my rounded value is going to be exactly the same, 49.8 expressed to the 10th. Part B of this experiment deals with ruler B. Ruler B has markings to the 10th, so every measurement should be to the 100th. The grader will look for that in your data. I've taken these 2 values now and used them in the next table. And the next table asks for the number of significant figures that are there. The 0 is significant, so we have 4 significant figures here. And now again, we'll be calculating the area of rectangle W, but this time we have 4 significant figures. Here's what the calculator gives me, and I'll round that to 4 significant figures. 154.5 are 4 figures, but I've got to look to the next digit to see if we round up or down, and we would round up. So that means that we're estimating here the last number is 0.6. Table 1.8, we're calculating the perimeter now with measurements using ruler B, and every measurement was to the 100th, so our calculated perimeter will be expressed to the 100th. Here's what the calculator gives me, 49.9. Well, that's only to the 10th, and I need it expressed to the 100th, so we'll add 1 more 0. Part C is improving the significance of measurements, and this is really an important part of the experiment. When you measure the coin diameter in the first part of this part C, you'll want to use ruler B. Ruler B is more accurate. And so you'll record to the hundredth. And the same thing is true down here when you measure the thickness of the stack of pennies. 1 penny, 3 pennies, 5 pennies, and so on. You'll want to use ruler B. And so the grader will make sure that each of these measurements is expressed to the hundredth. Table 110 now is where we do something interesting. Here in the first column are the number of coins in the stack. The second column will be your measured thickness expressed to the hundredth. The third column asks how many significant figures in your thickness. Well, I've got just 2 there, but that number may change. As you come down and you get 7 or 8 coins, you may discover that you've got more than 2 significant figures. The correct number of significant figures in the calculated thickness. Well, to get the average thickness, I'm going to divide the thickness by the number of pennies. And well, this column over here, you might say, well, hey, that's only 1 significant figure. But remember, these are exact numbers. We're infinitely sure how many pennies are there, so they have an infinite number of significant figures. That means that when we do this calculation, the number in this column is going to be the limiting value. Every number in this column will be the same as the numbers in the third column. The next column, this is what our calculator would tell us. I didn't have to use a calculator to divide 0.15 by 1, but this is what the calculator would say. And then finally, over here in the last column, I'll round my answer to the number of significant figures in this column. So as you come down, and if the significant figures increases, you may find that your average thickness rounded has more significance as well. Let's look at the next part. In the last part of the experiment, you're calculating the volume of a penny. The formula for volume is V is equal to 1/4 times pi. Pi, of course, is 3.1416, and lots of digits after that. The diameter of the coin squared, and T stands for thickness. And T will come from the table right above that. It'll be one of the values in this last column, the calculated average thickness of a coin, and you'll want to use the one that's most significant. So as you come down this column, if you find that the significance of your measurements increases, you'll want to use the one that's most significant. This value for T, the thickness, will probably tell you how many significant figures are going to be here. You'll do the calculation and then you'll round your answer to that number of significant figures. Let's look at the PostLab questions. Question 1 deals with your data and an area. So we'd be multiplying length times width. It asks you how many significant figures will be in the calculated area. And remember that when you're multiplying, you can just count significant figures and the smallest number wins. That should be the number that's expressed in your answer. Question 2 is perimeter. So again, you'll use your data according to the directions there. And remember that we count decimal places when you add, and it'll be the smallest number of decimal places that should be in your answer. Then once you have the answer, you can count the significant figures. So you can't count significant figures like you did in question 1. You have to wait until you have the answer and then see how many significant figures are in that correct answer. Number 3 is a little bit like one of the PreLab questions. We've got a measuring device. It's got the 1/10 markings. So What do you think? How many places should we estimate when we're using this particular measuring device? One more than the number of markings. Question 4 deals with that table that we were looking at when we had 1, 3, 5, 7, and 10 pennies. And perhaps you've noticed that the significance of your measurements increased as the number of pennies increased. In other words, with sample size. So if you wanted to find out who was going to be the next president, you ask 5 people, maybe you'd get a more accurate measurement of who's going to be the next president if you ask 1,000 people. Sample size increases the significance of measurements. Number 5, what's the shortest length that could be measured with ruler B that would contain 4 significant figures? Well, I could look at that and I could try to reason through it, but it's like a lot of math problems. Just get your pencil working. Try it with A, and try it with B, and so on, and then see which of those is the correct answer. Hey, I hope you have fun with this lab. Enjoy yourselves.